Find 1 minus root 3i to the 5 using de Moivre's theorem. Write the answer in standard form. So in order to use de Moivre's theorem, we need something. We know that the theorem states this: r cis of theta to the n is equal to r to the n cis of n theta. So we need the trigonometric form of this complex number. So I'll start by just actually drawing the complex number. That should help us a little bit. 1 minus root 3i, so 1 and then, down to root 3. So we've got a number down here. And so if we look at this, of course, this is 1 and then negative root 3. Then we can, of course, get the length here by using our Pythagorean theorem. That r is the square root of 1 squared plus negative root 3 squared. And that's, 1 plus 3, which is 4, and the square root of 4 is 2. And so we've got r. Let's go ahead and plug that in. R is 2. 2 raised to the n, which is 5. Cis of 5 times, and then we need to know what theta is. We need our angle here, and our angle shouldn't be too difficult to see. That here we have an angle where the tangent of the angle theta is negative root 3, and we see it's in the fourth quadrant, and so our angle theta then is 5 pi over 3. And so then that's, of course, what we plug in here, 5 pi over 3. Okay, and then we can simplify a little bit. 2 to the 5 is 32. Cis of this is 25 pi over 3. And then we need to go ahead and write this in standard form. So let's write this in its expanded form here. This is cosine of 25 pi over 3 plus I sine of 25 pi over 3. All right, and then we can evaluate these. 25 pi over 3 is coterminal with just 1 pi over 3. And so we can then evaluate that. The cosine of pi over 3 is 1/2. And then I times sine of pi over 3 is the square root of 3 over 2. And then bringing that 32 in so we can get our standard form, we get 32 times 1/2 is 16. So 16 plus, and then 16 root 3 times I.